This is day 2 of 7.5 in JSteele's Precalculus class. We are going to be further discussing how to solve trigonometric equations. So example 1, it says find all solutions of each equation. We have 2 sine squared of x minus cosine of x equals 1. Since we have a sine term and a cosine term, we are going to use a trig identity, so using a trigonometric identity, in order to further solve this. So we are going to substitute 1 minus cosine squared of x in for sine squared of x. So then we have 2 times 1 minus cosine squared x minus cosine of x equals 1. Distributing this 2, we have 2 minus 2 cosine squared of x minus cosine squared of x, or cosine of x equals 1. And since we have a cosine squared term, a cosine term, and a constant term, we know we are going to need a factor. So let's get everything over to the right-hand side. So we're going to have 0 on the left-hand side. After we add over the 2 cosine squared x, we'll have a positive 2 cosine squared of x, and a positive cosine of x, and a negative 1. Now this looks very similar to 2u squared plus u minus 1. So we can factor this into 2 cosine of x minus 1 and cosine of x plus 1. So first looking at 2 cosine of x minus 1 equals 0. To solve for cosine of x, we have to add the 1 and divide by 2. So cosine of x equals 1/2. Thinking of what angle gives a cosine value of 1/2. We know pi over 3 in the first quadrant because cosine is positive. And cosine is also positive in the fourth quadrant. And that angle with a reference angle of pi over 3 is 5 pi over 3. So we'll have x equals pi over 3 plus 2k pi. And we will have x equals 5 pi over 3 plus 2k pi. And now, so we just covered 2 cosine of x minus 1 equals 0. So now we still need to cover cosine of x plus 1 equals 0. To solve for cosine of x, we subtract the 1. So cosine of x equals negative 1. The only point where the only angle that gives a cosine value of negative 1 is at pi, where the ordered pair is negative 1, 0. So another solution we have is x equals pi plus 2k pi. Example 2, we have sine of 2x minus cosine of x. Here we are going to substitute 2 sine of x cosine of x in for sine of 2x. And this gives us 2 sine of x cosine of x minus cosine of x equals 0. So now we can factor out a cosine of x. And once we do that, we are left with 2 sine of x minus 1 equals 0. So for the first one, we're dealing with cosine of x equals 0. This happens at 2 points on our unit circle. That is at pi over 2 and at 3 pi over 2. So we will have x equals pi over 2 plus 2k pi. And we will have x equals 3 pi over 2 plus 2k pi. But thinking about this, pi over 2 and 3 pi over 2 are just pi units apart. So we can sum this up into saying x equals pi over 2 plus k pi. So this is one of our solutions. And now looking at the second part, we have 2 sine of x minus 1 equals 0. So just solving for sine. sine of x, we have sine of x equals 1/2, which that occurs at the value of pi over 6 in the first quadrant where sine is positive, and the other quadrant where sine is positive is quadrant 2, and the reference angle, or the angle in quadrant 2 that has a reference angle of pi over 6 is 5 pi over 6. So then we will have x equals pi over 6 plus 2k pi, and we will have x equals 5 pi over 6 plus 2k pi as two more solutions. So everything that is boxed up are our solutions. For the next section of the notes, we are going to talk about trigonometric functions of multiple angles. For our first example, it says find all of the solutions of the equation on the interval 0 to 2 pi. Example 1, we have 2 sine of 3x minus 1 equals 0. Notice we have a 3x opposed to just a normal x. So we are going to solve like 3x just with x. So just as if it were an x. So we're going to add 1 to both sides. Then we have 2 sine of 3x equals 1. Divide by 2. Then we have sine of 3x equals 1/2. We know that sine of an x value that gives a sine, or an angle measure that gives a sine value of 1/2 is pi over 6 in the first quadrant where sine is positive, and sine is also positive in the second quadrant where that angle is 5 pi over 6. So now we need to take 3x and set it equal to pi over 6 plus 2k pi, which is what our equation would be, and take 3x and set it equal to 5 pi over 6 plus 2k pi, which again is what our equation would be. And now the key step here is to divide all terms by 3 to solve for x. So if we were to divide 3x by 3, we are just left with x. If we are to divide pi over 6 by 3, we are left with pi over 18. And if we were to divide 2k pi divided by 3, we are just left with 2k pi divided by 3. Same thing goes for the other equation. We'll end up with x equals 5 pi over 18 plus 2k pi over 3. So then our solutions to the equation, since they can't just be the equations, the formula, or the x equals pi over 18 plus 2k pi over 3, because we are only concerned about solutions on the interval 0 to 2 pi. So we need to we start off with pi over 18 plus 0, which is just pi over 18, so that's one of our solutions. We need to take pi over 18 plus a k value of 1, which is just 2 pi over 3. And that gives us 13 pi over 18. So that's another solution. We also need to take add another k value to that. So when k is 2, we have pi over 18 plus 4 pi over 3, which equals 25 pi over 18. And that is on the interval 0 to 2 pi. And using the second equation, 5 pi over 18, adding 0, we're still left with 5 pi over 18, which is one of our solutions. When k is 1, we have 5 pi over 18 plus 2 pi over 3, which equals 17 pi over 18, which is another solution. And then lastly, we have 5 pi over 18 And when k is 2, we're adding 4 pi over 3, which equals 29 pi over 18. And this is on the interval 0 to 2 pi. And lastly, for our last example, it says find all solutions of each equation. This is just asking for the equations, the formulas that we get rather than on a certain interval. Number 2, we have the square root of 3 times tangent of x over 2 minus 1 equals 0. We're going to solve like x over 2 just as if it were x. So solving for the square root of tangent of x over 2, we first need to add 1 to both sides and then divide by 2. So we have tangent of x over 2 equals 1 over the square root of 3. Thinking of what angle gives us a tangent value of 1 over the square root of 3, that would be in quadrant 1 where tangent is positive at pi over 6. And again, we know it would happen again in the third quadrant. But when creating our formula, we'll have x over 2 equals pi over 6 plus k pi. So we don't really need to be concerned about the angle in quadrant quadrant 3 because adding pi would get us to that angle, and adding 2 pi would get us back to pi over 6. So that angle of 7 pi over 6 is unneeded. So right now we have x over 2 equals pi over 6 plus k pi. And instead of dividing by 3 like we did in the previous example, we are just going to multiply everything by 2. And that will get rid of the denominator. So now we have x equals 2 pi over 6 plus 2k pi. And just reducing, our final solution is x equals pi over 3 plus 2k pi.